Hello Algebra 2 students. Today we're going to look at factoring over the real numbers, which previously we've only been factoring over the rationals. And we've been doing that by using techniques such as greatest common factor, difference of two perfect squares, sum and difference of cubes, factoring by grouping, factoring trinomials. So today we're going to look at expanding that by using completing the square and the quadratic formula. So this first example is very familiar in the sense that I've given you a function before and said identify the zeros. In order to identify the zeros, you'd want it in factored completely form. So we're going to go ahead and try to factor this completely. When I look at x squared minus 4x plus 3, I'm seeing that that's a trinomial. My a value is 1, so I do not need to split this middle term. All I have to do is come up with two factors that multiply to 3 and add to negative 4. So that would be negative 3, x minus 3, and x minus 1. Those two numbers multiply to positive 3 and add to negative 4. Now for this one, there's not a GCF of 2, and since my a value is not 1, this is where you're going to do your cross. So I'm going to multiply these two numbers, which would be 54, and they need to add to negative 15. So what two numbers multiply to positive 54 and add to negative 15? The factors of 54 that come to my mind would be 6 and 9, and if I negate both of them, negative 9 times negative 6 is positive 54, and when I add them I get negative 15. Now remember, these are not going to be my last terms. This is how I split my middle term. So I'm going to come over here and factor this and then put it back in. So I have 2x squared. I'm going to split this middle term up into negative 6x and negative 9x plus 27. Now I'm factoring by grouping, so I'm grouping these first two and these last two. There's a GCF of 2x, and I'd be left with x minus 3. Here there's a GCF of negative 9. So if I take out negative 9, I'd be left with x minus 3. So now I'd be left with a GCF here and here of x minus 3. So I factor those out. So I take an x minus 3 out of here, which would make me left with 2x. Take an x minus 3 out of here, which would make me left with minus 9. So I've now factored this second trinomial. So I'll bring it back over here, x minus 3 and 2x minus 9. Now that this is in completely factored form, because I have all linear factors, I can identify my zeros. So here I'd have a 0 of 3, here I'd have a 0 of 1, here I'd have another 0 of 3, so I'm going to call this multiplicity of 2, and here my 0 I would add 9 and divide by 2, so that would be 9 halves. Okay, so this is what we've done previously. Now, what happens if I were to give you another one that looks very similar? Given f of x equals x squared minus 6x plus 3 and 2x squared minus 4x minus 7, factor completely over the real numbers and state the zeros. So it looks very familiar. Okay, so why don't you pause and get that copy down and then we can start again. Okay, so it looks familiar to the problem we just did. And if I try to factor it, I'd say, okay, f of x is equal to, I need, since my a value is 1, two numbers that multiply to 3 and add to negative 6. I'm not familiar with two numbers that multiply to 3 and add to negative 6. And the reason is because it's not going to be a rational number. So this is where we're going to use completing the square and quadratic formula. Just like in Algebra 1, when you couldn't solve a quadratic by factoring, your two other choices were completing the square or quadratic formula. So we're going to do that here. So what I'm going to do is I'm going to take this factor over here to the side, and I'm going to set it equal to 0. Because if I can figure out what my zeros are, then I can work backwards and write my factors. So I'm going to do this one by completing the square. Okay, so first step, your a value has to be 1 for completing the square, which it is. Then you are going to get the x's on one side and your constant on the other side. So I'm going to leave a blank and I'm going to subtract 3 over. So I'd have negative 3 plus blank. Because remember, if I add something to the left side of the equation, I have to add it to the right side of the equation in order for it to stay equivalent. That would be your additive property of equality. Okay? So in order to come up with the quote perfect number, and by perfect number, again, I mean that I want this to be a perfect square trinomial, meaning I want it to be able to be factored into a binomial squared. Okay, so in order to do that, you take your b value, which in this case is negative 6, divide by 2, and square it. So negative 6 divided by 2 would be negative 3. Negative 3 squared is 9. So my perfect number would be 9 that I would add to both sides. So this would factor into x minus 3. And it's minus 3 because notice we want negative 6 here. Okay. I also mentioned to you guys in last night's video where we reviewed completing the square and quadratic formula that it'll always be equivalent to that value, which simplifies to negative 3. Alright, so that is equal to negative 3 plus 9, which would be 6. Now we'll finish completing the square by taking the square root of both sides. Remember, when you take the square root, you have to have plus or minus. So we'll have x minus 3 equals plus or minus the square root of 6. Then we can finish solving for x by adding 3. So what I've determined here is I've come up with 2 zeros for this factor. I've come up with the 0, 3 plus the square root of 6, and the 0, 3 minus the square root of 6. Okay. Now remember, over the past week we've been looking at polynomial functions where I've given you a 0 and said, what are the factors? And you were able to tell me if I said, and I'm going to write this here, but you don't have to write this, so don't write this. If I say x equals 2 is a 0, what can you tell me? You've been telling me, well, that means x minus 2 is a factor. Okay, so if x equals 3 plus the square root of 6 is a 0, x minus this would be a factor. So I would have x minus, and remember we want the whole thing, and you don't have to distribute the negative and combine if possible. You don't. You can just leave it like that. So here's my other 0. So my factor would be x minus this 0. Okay. This just looks crazy because it's got the square root of 6, but the square root of 6 is just a number. It's just not a rational number. Okay. So what I've determined is that the factors of this are these two factors. So I'm going to write that up here, x minus 3 plus the square root of 6, and x minus 3 minus the square root of 6. Okay, so that's the factors to the first one. So I'm working on factoring this completely. So my next polynomial here, that's the other factor, I need to factor that further. So I have 2x squared minus 4x minus 7 equals 0. So I'll set it equal to 0. I'll solve it. I'm going to do completing the square again. Notice that my a value here is not 1, so I have to get it to be 1. So in order to do that, I'm going to divide everything by 2. Now remember, if it's an equation, this is totally fine because my equation is still balanced. But remember, we're using this method in order to figure out how to factor this. So when we want to look at the factors, we when we started, divided by 2. So we technically took a factor of 2 out. So we're going to have to add that back in later. So just keep that in mind. Here I'm taking out a factor of 2. So when I write my factors, I've got to put that 2 back in there. So you could, if you wanted to, right now, go ahead and put the 2 in there. I'm actually going to move this down so we have some room here. If you wanted to put the 2 in, now you could put it here at the end, or you could put it in front, whichever you prefer. So you don't forget, that's a great option too. Okay, so I'm going to move my constant over and have my variables on the other side. So I'd have x squared minus 2x plus blank equals, add 7 halves, so that would be 7 halves plus blank. So I'm going to find my perfect number. That's my b value, negative 2 divided by 2 squared. So that would be negative 1 squared, which is just 1. So I'm going to add 1 to both sides of my equation. Now I'm going to factor this. Remember, we've created this to be a perfect square trinomial. That's the whole point of completing the square. So I can factor this into x minus 1 squared. And here I can add these two. Now 7 halves plus 1. 1, if you need to go on the side of your paper and add those, you can. Or you could say, well, 1 is the same as 2 out of 2. So 7 out of 2 plus 2 out of 2 would be 9 out of 2. Okay. At this point, all of this can still be done without your calculator. Alright, so our goal is to get x alone. So we're going to take the square root of both sides. Now be careful, because when you take the square root, remember you need plus or minus. So we have x minus 1 equals plus or minus the square root of 9 halves. And we'll deal with that in a second. I know it probably looks a little funny, and it should, and we'll deal with it in a second. I'm going to add my 1 over, though. So I'm going to add 1 to both sides. So I have x equals 1 plus or minus. Now, the square root of 9 halves, we could write it as the square root of 9 over the square root of 2. Because the square root of 9, you guys know, is 3. Now, in geometry, and possibly in algebra, depending on who you had, you might have been told that you can't have a radical in the denominator. You have to, what we call, rationalize the denominator. So you need to get the radical out of the denominator. So basically, all you have to do is multiply by whatever your denominator with the radical is. So I'm going to multiply by the square root of 2 over the square root of 2. Now the square root of 2 divided by the square root of 2 is really just 1. It's just what I consider like a fancy one. Okay, we're just manipulating the way that this looks. So I could rewrite this as x equals 1 plus or minus 3 times the square root of 2 would be 3 square roots of 2. We can't multiply these because that's a radicand and that's a not. Over the square root of 2 times the square root of 2 would be the square root of 4, and the square root of 4 is just 2. Okay, so there I have found my zeros for this equation up there, but remember we only want the factors. So I can take my zeros, just like we were talking about here. If I say x is equal to 2 is a 0, x minus 2 is a factor. So the factors here would be, and I'm going to move this again so I have more room, would be x minus 1 plus 3 square roots of 2 over 2, and x minus 1 minus 3 square roots of 2 over 2. Okay, there's 2 zeros here. There's the first one, which is 1 plus 3 square roots of 2 over 2. And then there's the second one, which is 1 minus 3 square roots of 2 over 2. So what I did here, guys, is I took this and just said x minus that. Just like we did here, when my 0 was 2, I just did x minus 2. So here my 0 is that, so I just do x minus that. Okay? Hopefully that makes sense there. If it doesn't, remember guys, just put a note on the side of your paper and say, like, I don't know what you did here, or how did you go from this step to this step. And we'll be sure to go over those first thing before we start working on some practice. Okay? So at this point, you probably are not remembering that we took out that factor of 2 to remember to put it back in. Okay, so I would suggest as soon as you divide by whatever your a value is here, that you write it in your factors so you remember to put it there. So this is your function factored completely. So then it says state the zeros. So this 2 doesn't have a 0. My 0 here, notice guys, I really already have my zeros. I already found them. We found our zeros and then worked backwards. Okay, so right there in this blue box and this blue box are my zeros. So all I have to do is restate it. X is equal to 3 plus the square root of 6. X is equal to 3 minus the square root of 6. X is equal to 1 plus 3 square roots of 2 over 2. And x is equal to 1 minus 3 square roots of 2 over 2. And these are all my zeros. Okay. Now, I totally get that these look weird. They do, but it's just because they're irrational. You could, not that I'm telling you to, but you could put this in your calculator and just get the decimal value for it. You know that 6, the square root of 6 would be between the square root of 4 and the square root of 9. We know the square root of 4 is 2. The square root of 9 is 3, so the square root of 6 has to be 2 point something. Okay, and it's a little closer to 4 than it is to 9, so it'd be closer to 2 than it is to 3. So again, it's just a number. You just don't like it because of the radicals. Okay. All right, let's try one more, and then we'll call it quits for the night. So given this function f of x is equal to this, factor completely over the reals, identify the zeros, identify the end behavior, and sketch the function. So go ahead and pause and get that copied down, and then we'll get started. Okay, so for part A, we are going to factor it completely. So in order to do that, I'm going to take each of my factors separately. I have x squared minus 2x minus 4. I'm going to check and see, can I come up with two numbers that multiply to negative 4 and add to negative 2? No, I can't, which means that I'm not going to be able to come up with rational factors, so I'm going to have to complete the square, do quadratic formula. Since we did completing the square on both of the ones in the last example, let's do quadratic formula here. So in order to do the quadratic formula, that's where we take our quadratic, we set it equal to 0, we identify our a, which is 1, our b, which is negative 2, and our c, which is negative 4. We then write our formula down, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And then we substitute in. So negative b, if b is negative 2, the negation of that would be positive 2. So we'd have 2 plus or minus the square root. Negative 2 squared is 4. Remember, I'd suggest you square it before you put it in here, so you don't have to worry about the signs. Minus 4 times my a, which is 1, times my c, which is negative 4. Okay, and I'm just going to extend that out a little bit. All over 2 times my a, which is 1. So now I'm just going to simplify. 2 plus or minus the square root. This says 4 minus 4 times 1 times negative 4. Order of operations says I have to multiply first. So when I multiply this, I get negative 4. Times negative 4 would be positive 16. So 16 and 4 would be 20. All over 2 times 1, which is 2. Now, don't get excited and divide this 20 by 10. This 20 is under the radical. It's your radicand. It can't be divided by 2. Only the coefficient that's here could be divided by 2. So let's simplify the square root of 20. I'd come over onto the side of my paper and simplify it rather than doing it in the middle of the problem. It's just going to make it look more congested for you. So I would take 20 and split it into the square root of 4 and the square root of 5. The square root of 4 is 2. So the square root of 20 is equivalent to 2 square roots of 5. So I could say 2 plus or minus 2 square roots of 5 all over 2. Notice I could take a factor of 2 out of this numerator and simplify it with this one. Or you could split it up if you wanted, whichever you'd prefer. You also could split both of your answers, the plus and the negative, if you'd like. 2 divided by 2 is 1, so we have 1 plus or minus the square root of 5. So there's really two answers here, remember. We have x equals 1 plus the square root of 5, and we have x equals 1 minus the square root of 5. So in order to find my factors, remember these are my zeros, so I'm just going to do x minus this. So that would be 1 plus the square root of 5. And I will do x minus this, and that would be 1 minus the square root of 5. Okay, so those are my factors for this first quadratic here. Now I'll do my second quadratic. It's 3x squared plus 8x minus 3. I'm going to set it equal to 0. Okay. You could do completing the square if you wanted to. This problem would really be obnoxious to do completing the square, because remember your a value has to be 1, and so if I divide this whole thing by 3, I'd have 8/3. You would then have to take half of 8/3 and square it. It would just be really obnoxious. So I'm going to do quadratic formula again. My a value is 3, my b is 8, and my c is negative 3. So we're using the same formula, same quadratic formula. X equals, so negative b would be negative 8, plus or minus the square root of b squared, so 8 squared would be 64, minus 4 times my a value, which is 3, times my c value, which is negative 3, all over 2 times 3. Now notice in this problem, just like the one back here where we divided out 2 because we are completing the square, right here we're dividing out a factor of 3. Now I agree it's not going to change your zeros, but it does change your factors. So at that point, instead of trying to remember later, I would come down and say, okay, f of x is equal to 3, because I took that out, this factor and this factor, and then we can finish up getting the other two factors, but at least now we don't have to worry about trying to remember to bring that 3 down later. Okay, so we can finish this up here. I have x equals negative 8 plus or minus, simplifying this, 64 minus 4 times 3 times negative 3. Order of operations, you have to multiply before you can subtract. So that's 9, that's 36. It would be positive because of the two negatives. 64 plus 36 would be 100. So we'd have negative 8 plus or minus the square root of 100 all over 6. So I can simplify that. The square root of 100 is a perfect square, so that's nice. We could call it 10 all over 6. So I now have negative 8 plus 10 over 6, and I have negative 8 minus 10 over 6, both of which I could simplify further. Negative 8 plus 10 would be 2/6. Negative 8 minus 10 would be negative 18/6. So here I have a third, and here I have negative 3. So notice these are not irrational, which means I could have actually factored this using one of my skills or techniques that I used previously. So you could have multiplied a times negative 3 and said, okay, that's negative 9, and split your middle term. You would have ended up in the same spot, and that would have been fine. You can always use quadratic formula in completing the square. Those will work for any quadratic. The only thing that won't always work is your factoring techniques for rational numbers, which is why we have to do this. So maybe you noticed from the beginning that, hey, I think I can factor this one, and that's fine too. If not, and you did this out, that's okay too. So x minus 1/3 would be another factor here, and x minus negative 3, so it would be x plus 3 would be your other factor. Okay. unless I tell you specifically you have to solve by completing the square or you have to solve by the quadratic formula, you can do it however you would like. The reason I made you go through this one is because I wanted you to see what happened when we divided out that 3. So here is your completely factored form. If I want the zeros, remember we really already have those because that's what we use to write our factors. So we have 1, 2, 3, 4. This doesn't give me a 0. So my zeros would be x equals 1 plus the square root of 5, x equals 1 minus the square root of 5, x equals 1/3, and x equals -3. Part C asks to identify the end behavior. So my original, I'm going to extend the page and move this down. So my original function, I'll rewrite it down here again just so you guys have it. F of x is equal to parentheses x squared minus 2x minus 4 and 3x squared plus 8x minus 3. So in order to find my end behavior, remember I would need it in standard form so I can identify my dominant term. So in order to do end behavior, we write as x approaches infinity, f of x approaches, and we'll fill that in, as x approaches negative infinity, f of x approaches what? Now remember, you don't have to multiply this all out. You can just identify what would my dominant term be. So by looking at this, if I were to multiply it all out, my leading term, or my dominant term, would be this x squared times 3x squared. So that would be 3x to the 4th. So now I can use the generalization that we did in class, or you could pick values close or approaching to infinity and approaching negative infinity. But the generalization says that if this is an even degree, my ends are headed in the same direction. So they're either both up or both down. And because my leading coefficient is positive, they're both headed up, which would mean they're both headed to infinity. Okay? So far, we have completed part A, part B, part C. Part D asks us to make a sketch. So for our sketches, I will label my axes, x and y. Okay. I want to put my zeros on there. So I know I have a 0 at -3. I know I have a 0 at 1/3. So that would be approximately here. Now these two are a little harder to identify where they're specifically located. Okay. However, we can do it still without a calculator. We can estimate, because 1 plus the square root of 5. The square root of 5 is not a perfect square, but it's pretty darn close to the square root of 4, which we know is 2. So this would be just a little bit over 2. So if I had 1 plus 2 in sum, that would be 3 in sum. So I can put it approximately there. Then 1 minus 2 in sum. If we take 1 and subtract 2, we're at -1, and if we subtract a little bit more, we're at -1 and a little bit. So it would be approximately there. Okay. In the future, you guys will have your calculators, but you should be able to, in, let's see, 7th grade, you approximated radicals. So you should be able to get an approximation like this between two integers. Alright, so our ends, we said, were headed in the upwards direction. And each of these zeros has a multiplicity of 1, so they're going to intersect. So we'll come down and up and down and up. Remember, we're not going to label our y-axis because we're not sure where the relative mins and maxes are without our calculator. Okay, so this really, guys, this last problem here, A, B, C, and D, really sums up everything that we've been working on since the beginning of the year, technically, because it's got all the factoring, it's got the distributing, and so forth. So if you're comfortable with this, not maybe you can produce especially this on your own yet, but if you're pretty comfortable with this and we're able to follow it, you're in a good place. If you're not comfortable with it, please be sure to find a time to come see me so we can work on this and get you where you need to be. All right, have a good night, guys.